Okay, here we go with homework 5.8. And here we go. Let's just jump in here. It says you got a graph. That's a normal, standard normal curve. Actually, a normal distribution curve, so a bell curve. And it's got a mean of -2, which is right here in the middle. And it tells you it has a standard deviation of 2. And what they want you to do is shade the corresponding region under the standard normal density curve. Okay, so the difference between a normal distribution and a standard normal density curve is standard normal is going to have a mean of 0 and a standard deviation of 1. Okay, so basically here's what you got to do on this problem. You're going to need to say, well, how many from -2 to 0, how many standard deviations is that in this situation? Well, if the standard deviation is 2, that's just one standard deviation. Okay? So over here, I would come out and just put a mark at 1 standard deviation. Now I need to come over here and say, okay, how far is this? This distance from -2 to -5, that's a distance of 3. Or if you want to think of it as -3, okay? Divide that by 2, which is our standard deviation, I get -1.5. So what I would do over here is come out and put a -1.5. So basically I'm looking for all the area and then shade in between here, okay? Because basically on a standard normal density curve, I'm just looking for the area between 1 standard deviation to -1.5 standard deviation. And that's something we're going to be doing here in the next few problems. But right now they're just wanting you to be able to sketch that. All right. Again, the main thing here is knowing the difference between what is a normal distribution and a standard normal density curve. Again, standard normal density curve has a mean of 0 and a standard deviation of 1. All right, jumping over to the next one. So here it says, according to recent surveys, the salaries of assistant professors have a mean of $41,750 and a standard deviation of $6,500. Assuming that the salaries of assistant professors follow a normal distribution, find the proportion of assistant professors who earn less than $50,000. All right, so I'm always going to draw a picture on these. So, and I would suggest you do. If you ask me for help, I'm going to ask you to draw me a picture. So it's a normal distribution. It's got a mean of 4,750. So that's going right in the middle. It's got a standard deviation of 6,500. I'll just keep that off to the side. And I want to find the proportion of assistant professors who earn less than $50,000. Okay, so if this is 41,750, 50,000 is somewhere over here on that side of the mean. And I want to know what's the proportion of people that are getting less than that. So I'm looking for this area right here. Now, even before we start, I'm hoping you're going to be thinking, well, that's over 50% of the data, or 50, this area I'm finding is going to be over 0.5 because from here over here is 0.5. There's half because the area under this normal distribution curve is 1. So I've got to have half on one side, half on the other. Now, your calculator, the Alex calculator does this, but I would suggest you learn how to do this on your TI. You've got, if you go under the, you see, you have a VARS button. Above that is the distribution button. So if you hit second VARS, you'll access this distribution button. All right, and then if you go down to number 2, at least number 2 on mine is normal CDF. This is a normal curve, and we're going to use that normal CDF. And depending on what model you have, like right now mine's saying lower bound or lower, upper, the mean, and the standard deviation. Those are the things that I would have to fill in for. All right. So if I'm looking at my picture here, my lower bound is actually negative infinity out here. Okay. I don't have a way of typing in negative infinity for lower bound, so I'm just going to type in negative and a bunch of, maybe 6 or 7 nines. Okay. I want a really low number there. My upper bound is 50,000. So I'm going to type in 50,000 for my upper bound. The mean is 41,750. Standard deviation is 6,500. I enter that information in there and make sure I get them in the right place. Hit paste. I'm coming out with my answer. 0.8978 would be the answer to this problem. So it's about 89.78% of the professors make less than $50,000. But this would be my answer here. Okay. Just real quickly, if you have a model that's not as updated, what you're going to have to do to type this in is do normal CDF. That comes up on your screen, and then it's got a parentheses. You'd have to type in the data like this with commas between them. You type it in like that, hit enter, and you're going to get the same thing we got right there. Okay? Normal CDF. Important, you're going to be using it a lot. Going to the next. Okay, standard, normal, advanced. I think there's a basic one we better do first. Let's try, let me see. Okay, we'll do this one. All right, so let's just read what we got here. It says, let Z be a standard, normal, random variable. Okay, remember, standard, normal curve. This is 0. Standard deviation is 1. It says, use the calculator provided or this table. You're going to be using your TI to determine the value of C. All right, and it's so these C's, these are standard deviations. So it wants to know 1.1 standard deviation would be to the right since it's a positive number. And the C, this other one, is going to be some value over here. I know it's over here because it says the area between these two things is 0.8453. So this area between these two marks, that's the area. So that's over 0.5. So I know that's more than half. So it's got to come all the way, reach over here somewhere. The question is, what is this number? How many standard deviations do I need to come this way in order to get this much area in between here? Okay, so this is a two-step problem. All right, and you're going to be using something called inverse norm to figure this out, to help you figure this out. So let's see. The first thing I would do here is maybe find out, and you can go about these different ways, but I think what I'm going to do first is find out what's this area between 0 and 1.1. All right, and I'm going to do that by going to my normal CDF. So I type in normal CDF, and my lower bound here is 0, and my upper bound is 1.11. 0, 1.11. I've got a mean of 0, and I've got a standard deviation of 1. I type those things in. I get an area of 0.3665. That's this area right here. All right. So if I subtract that number from this total number, this 80.8453, do that subtraction. Do that real quick. 0.853 minus 0.3665. Come out with 0.4788. Okay, so this area over here is 0.4788. All right. So my question is, what is this number right here? So I've got this thing called inverse norm, and you find it by doing what do? You go to that second vars, get your distribution, and it's the third one. It says inverse norm. And what it does, if you hit that, the first thing it asks you for is area. All right, now what I want to do though, and it's got the mean, and it asks you for mean and standard deviation as well. So my mean is 0, my standard deviation is 1. The question is, what is the area? Now what it's going to need for me to do is, if I type in 0.4788, it's going to give me the wrong answer. What I need to know is, really, what is the area over here? Because it always gives me that value to the left of whatever I type in. So I am going to figure out this area right here in red by saying 0.5 minus 0.4788. 0.5 because, remember, from the center over is 0.5, and from here is 0.5. So if I do 0.5 minus 0.4788, and then my area and my, see if that'll give it to me. Yep, it gives me a value of negative 2.0, around these two places, 2.03. All right, makes me feel real good since I got a negative value. It had to be negative because it's on the left side of the mean. That means I need to come 2.03 standard deviations over for this value here in order to get the original problem. So if I go back and I got a lot of stuff drawn here, but let's think about what we started with. The question was, you had a value of 1.1, a mean of 0, standard deviation of 1. I know now that between negative 2.03 standard deviations and 1.1 standard deviations, there's an area of 0.8453. All right, it's going to take some practice, but you're going to get it. All right. So, yeah, ask me some questions. If you got some problems, let me know. It's back here. Oops. Nope, maybe not. The one there. I think that's it.